Hi everyone, meteorologist Steve Caparotta here with another episode of Coast and Climate. But this week on the podcast, we're going extraterrestrial with our topic, the James Webb Space Telescope. This week, we've got some really neat, exciting stuff. The first images being released by NASA. And to tell us more about some of these images that we have gotten a first look at, joined now by Dr. Matt Greenhouse. He's an instrument payload project scientist for the Webb Telescope. Dr. Greenhouse, thanks for being here this morning.
Thank you for having me.
All right, so obviously very exciting week for you guys, incredible images that we're seeing. What I'd like to do is you've released a series of some of the first images that we've got from the Webb Telescope. So let me pull up some of these. So the first one I'm bringing up here, I believe, is the Karina Nebula. Tell us what we're looking at.
You're looking at a giant molecular cloud of gas and dust, which is the birthplaces of stars. And in this image, which we're seeing in unprecedented detail for the first time, we can actually see lots of baby stars that are forming here. Just off the image to the top are some newly formed stars that are producing a lot of strong ultraviolet radiation, which is eroding this cloud. And you can even see streamers of gas coming off the cloud. So this image really shows the power of Webb's ability to see fine detail. Webb will give humanity its first high-definition view of the infrared universe.
All right, so another one of the images that we got to look at, I think this is the one that we got to see initially from President Biden, but Ssmacking 0723 is how it's kind of labeled. Tell us exactly what we're looking at here.
It's incredible. It's a very, what we call a deep field of an area on the sky. And the most distant objects in this image, they emitted their light 13.1 billion years ago. The universe is 13.7 billion years old. So in this image, we're seeing back almost to the formation epoch of galaxies. You can see in this image some of the galaxies are smeared out into an arc type of shape, and those galaxies are being gravitationally lensed by clusters of stars that are in the foreground of the image. There's a lot going on here, and it's very, very exciting. The Webb has produced this image in just a few hours. The similar image produced by the Hubble Space Telescope took 10 days.
Yeah, it's pretty remarkable to see that progress, how quickly things have changed, and this big leap that you've made there at NASA with what we're seeing with Webb. So let's bring up another one of these images now. This one is called the Southern Ring Nebula. Tell us what we're looking at and what the side-by-side is all about here.
This is the death throes of a star like the sun. So when our star dies, 4 or 5 billion years from now, it'll produce a nebula that looks much like this. Here, a star has completed its life, and when it dies, it throws off its atmosphere in successive layers to produce this nebulosity that you see. On the left is an image taken with the near-cam instrument, and on the right is an image taken with the mid-infrared instrument. So on the right, the emission there is aromatic hydrocarbon molecules, where on the left, the emission is primarily ionized hydrogen.
And we're also getting a look with at some of the galaxies out there, right? So I'm going to pull up this next image, this one called Stefans Quintet. Tell us what we're seeing in this one.
This is an incredible image. This is a set of interacting galaxies. The one on the left is really in the foreground, so it's not interacting with the other four. But the other four are interacting. They're colliding galaxies. And you can see star formation regions that are shown in red there that are being excited by the interaction of the galaxies. And Webb will be doing a lot of studying of galaxy collisions to understand how that process affects the rate and efficiency of star formation.
All right, now I want to bring up one more image before we kind of wrap it up here with you. So we talked about galaxies. We're also getting a look at exoplanets. Tell us about this one, WASP 96b.
This is a giant. This is a hot Jupiter giant planet. It's small. It's I think about the size of Saturn, the mass of Saturn, and you're seeing a spectrum of its atmosphere, which is showing that the atmosphere contains water vapor. So this is discovery of water vapor in the atmosphere of this exoplanet. And Webb will be doing lots and lots of spectroscopy of exoplanet atmospheres to search for chemistry that is indicative of life on the exoplanet. And water is very important for the search for life. We don't look for water because the alien life might get thirsty and need something to drink, but rather in order to have life occur on a planet, one needs to have a liquid solvent available on a planetary scale, and water is what we're most familiar with.
So the Webb Telescope, we're getting these remarkable images already. It's an infrared telescope. Can you tell us how that operates and how it's a little bit different from some of the other telescopes that NASA has used?
Sure. The infrared telescope, the Webb, observes light that is longer in wavelength than the red light that our eyes can see. Our skin is sensitive to infrared light. If you hold your hand near a warm radiator or stove burner, you feel the heat. What's happening there is your skin is actually sensing the infrared light emitted by the warm object. And so the Webb telescope is designed entirely as an infrared telescope in order to see the light that is emitted by the first galaxies. That light's been traveling to us over all of cosmic time. And as it travels to us, its wavelength is stretched into the infrared by the expansion of space. So we had to build an infrared telescope to see those first objects.
All right, so before I let you go today, we're seeing remarkable images already here in the initial days of some of these releases that you guys at NASA have put out. What can we expect to hopefully see out of Webb in the future?
You can expect a steady stream of fantastic imagery and even more fantastic scientific discovery, much as the way you saw with the Hubble Space Telescope mission. The Webb should rewrite a lot of science and engineering textbooks, and the mission is just getting underway.
Simply incredible. I think so many of us in awe as we get a look at these first images. So Dr. Matt Greenhouse, thank you so much for your time this morning, and best of luck on this incredible project going forward.
Thank you for having me.
All right, again, that's Dr. Matt Greenhouse with NASA telling us all about the James Webb Space Telescope. Just incredible when you look at this image behind me and what we can maybe expect in the future. We'll be back next Thursday, new episode of Coast and Climate, completely switching it up back here on planet Earth. There's a new project being launched called the Community Lighthouse Project, and this is about building some solar-powered resiliency hubs that especially will come into use in the wake of hurricanes, hopefully for sheltering, give people a place to cool off. A really neat idea. And churches are going to be heavily involved in this. I'm going to be joined by one of the pastors of those churches that's involved in the Community Lighthouse Project next Thursday at 10 o'clock. He'll tell us what it's all about and how Baton Rouge is potentially even going to get involved in that project. So hope to see you back here next Thursday at 10. In the meantime, you can catch all the past episodes of Coast and Climate on WAFB Plus and on our website.